Hello and welcome to this section of the Matlab tutor. We're going to continue working with matrices. We're going to talk about how to find the norm of a matrix, the eigenvalues of a matrix, and the characteristic polynomial of a matrix, which, as you probably know, is used to calculate the eigenvalues of a matrix. If all of this sounds like Greek to you, it just probably means you haven't studied eigenvalues before in matrix algebra, and that's okay. And if you haven't studied that, you can just skip this section. Those of you who have taken linear algebra or some other matrix algebra course have heard of these terms before, and they're used in science and engineering quite a bit. So let's go ahead and make a matrix. We'll call it A, and we'll just put whatever we want in here. 1, 2, 2, 3. Next row, 4. Let's do it like this. 4, 5, 6. Next row, 7, 8, 9. So we'll just make a quick square matrix, just filled with random numbers. Now, if you want to calculate the norm of a matrix, you just have a function called norm, and you pass it the matrix. So in this case, Matlab calculates 16.8 and some change as the norm. Now, I'm not going to get into a discussion of how you calculate the norm by hand or even all the details of what it means, because to be honest with you, it's a discussion kind of beyond the scope of teaching you how to use Matlab. Some of these functions, as we go along, you'll have to know what they are mathematically, and we're using Matlab as a tool. If you don't know what the norm of a matrix is mathematically, then that's something that we can learn. You can learn by looking at my other videos in matrix algebra and linear algebra. So that's how you calculate the norm of a matrix. There's no gotcha to it. You just pass it the value. Now, how do you calculate, let me put matrix A back up there, the eigenvalues of a matrix? That's something you're constantly being asked to do in lots of science and engineering problems. It's very simple in MATLAB. EIG stands for eigenvalue, and you just pass it the matrix name. And so there you go. You get your values. In this case, it's a 3 by 3 matrix, so we expect to get 3 eigenvalues back, and it returns it in a column vector for us, 16.1, negative 1.1, and then we have roughly 0 there. Now, along with that, so it's very simple, by the way, just calculate the eigenvalues. You just pass it the vector, just like we've done. Doing it by hand, typically what you're asked to do is to first calculate the characteristic polynomial, right? The characteristic polynomial of the matrix, and then from that you find the eigenvalues. So to find the characteristic polynomial, it's just poly, and you pass it the matrix. So the characteristic polynomial is this guy right here. All right, and so now we have the characteristic polynomial. This is how you would find it here using the poly command. So if you wanted to just sort of close the loop and show yourself and prove to yourself that this is the characteristic polynomial, then you can solve this for the roots of the characteristic polynomial, and those should be the eigenvalues that we calculated before. So this characteristic polynomial is lambda cubed minus 15 lambda squared minus 18 lambda minus 0. That's the characteristic polynomial. The lambda that I'm talking about, that's just in the definition of what the characteristic polynomial is. When you study linear algebra, you know that it's all in terms of lambda. So to solve this characteristic polynomial, you want to set it equal to 0 and solve for the lambdas. So there's a built-in function in MATLAB called roots to find the roots of any polynomial. So I can just pass it like this. I can say find the roots of the polynomial, and I'm going to go ahead and pass it the matrix and form this polynomial and say find the roots. MATLAB will compute the roots just like this. And if you notice, this is the same thing that we got when we actually just pass the matrix directly to the eigenvalue function. We get the same things. So I think by doing this exercise, you can prove to yourself that this is indeed the polynomial, the characteristic polynomial of the matrix that we provided. If you solve this characteristic polynomial, you'll get the eigenvalues back, which is the same thing as using the built-in eigenvalue function that MATLAB provides. And to close this out, I'll say that eigenvalues and characteristic polynomials and things are things that you constantly use in matrix algebra and linear algebra. In science and engineering, they're important concepts, but if you've never heard of an eigenvalue, then you can kind of not even worry so much about this section, because it's something that, it's like anything else in math. Once you learn about it and you learn how it's useful, then you go and you find that, and you use that tool to solve problems. So once you do encounter an eigenvalue, you'll know how to use MATLAB to calculate these for you.